then with that, I'll bring in the next speaker, which is Ashish. Quinn, I'll put you back in the lobby. Thanks a lot for your presentation, man.
Thank you.
All right. Hey, Ashish. So yeah, let me remove that banner. So you're going to talk about mastering PyTorch. I would say that the floor is yours. You're not sharing your screen yet, though, so I'm still waiting for that.
Thank you, Kris. I'm going to share it now. Can you see it now?
Yes, here it is. I'll remove myself as well. Yeah.
Thank you so much. So yeah, hello everyone, and thanks once again, Kris and Data Science Leuven, to give me this opportunity to share not just my writing experience of this book, Mastering PyTorch, which I published in February 2021, but also to share with you like few glimpses of what the book is about, and yeah, like give you an example of how the exercises I have written in the book look like. So without wasting much time, I will go into it straight. So I'm not going to cover the details of the book, obviously, because I only have 20 minutes and that's something for the readers to read the book. But what I intend to cover in this presentation is a few things. First is the motivation, which is why I wrote this book, like why another deep learning or why another PyTorch book, and then the process. So for those who are interested in writing a machine learning or a technical book, just wanted to share what the process looks like. And then obviously a like quick peek into the book, what it is about, what are the contents very briefly. And finally, I would like to wrap up the presentation with a live coding exercise, just to give a feel of how the exercises in the book are. So firstly, the motivation. So last year, I have been thinking about writing a deep learning book for a long time, but my inspiration comes mostly from this book, this great book called Head First Java. So Head First is a series of books, and this one is about the Java programming language. The speciality of these books is they are incredibly illustrative. So even a layman can at least read them and get some sense out of them. So it's very relatable and very applied. And so I felt that that kind of a book is missing, at least in the deep learning or machine learning paradigm. So this was my initial inspiration, and I had some conversations with the publisher Pact, and they wanted to write a PyTorch specifically book. So I used PyTorch as the medium of explaining deep learning in as applicable and as illustrative way as possible. But also besides Head First Java, I would like to address the question on why yet another book, yet another deep learning book. So we all know we have a lot of literature already, and even I have read all of these books, at least some chapters, but I still felt some aspects were either missing or were a bit too much. So one of them, for example, was that the textbooks have a lot of advanced theory, which I personally did not need the knowledge of in my 6+ years of working. What I really needed more is applied knowledge. So that's something I wanted to emphasize in the book I wrote. And also I wanted to add the perspective of an engineer, of a machine learning engineer or a deep learning engineer. And by that, I mean aspects such as productionizing a machine learning model, using machine learning in the cloud. And finally, in PyTorch, there is a very rich ecosystem of libraries. Think about Fast AI or PyTorch Lightning, which really facilitate a lot of advanced deep learning related work, which few people know about how to use them precisely. So I wanted to add that information as well in this repository. So these were like a few kind of pieces of inspiration or motivation for me to actually put together an altogether book for PyTorch. All right, so about the process of writing a technical book, I could look back and make out like a few steps. So it all begins with deciding a table of contents and agreeing with the publisher about the table of contents. And then you write a few words about each of the chapters that you have mentioned, so that you are sure you align with the publisher what you are going to write within those chapters. The most important bit after that is to agree on a schedule where each chapter has a precise deadline, and then you start writing the chapters sequentially. I used Google Docs as a tool for writing the chapters, nothing fancy. And when I was writing the chapters, basically I first wrote some scaffolding text, just the various subsections. Then I wrote some code for the exercises. It's very important to get that right. That's the most important part, to test them and also to push them to GitHub, and to create the diagrams for illustrations wherever applicable. And I used, again, a very simple open sourced website called draw.io for making the diagrams. And finally, just complete the entire chapter, like fill up the chapter text and make it concrete, and review the chapter again and again with the publisher at different levels, at the level of language, at the level of code, and then even higher levels such as editorial or category reviews. Category review here could be things like whether the topic really aligns with the initial concepts that were written in the briefs. So this, to me, like, this is basically the life cycle of writing a technical book. All right. So like, apart from the motivation and the process, what exactly this book is about. Firstly, this book is 450 odd pages long, split across 14 chapters, which are further split in 4 sections. And the 4 sections are like the following. So you have the overview of PyTorch, the deep learning framework. And when we say deep learning framework, it's kind of necessary to also remind about deep learning again. So that's the idea of the first section. Then there is an emphasis on some advanced neural architectures in the second section to go deeper into the actual knowledge base. The third section is really mostly focused on applied, basically deep learning applications such as generative models, but also deep reinforcement learning. And the final section is really coming from the perspective of a deep learning engineer, so productionizing PyTorch models, but also coming from the perspective of utilizing the PyTorch ecosystem, so using libraries such as Captum for interpretability, or some AutoML libraries, and also Fast AI for rapid prototyping. So just to give a glimpse of what like some of the chapters have in them. So when we are overviewing the deep learning concepts, the book discusses layers, activations, losses, just to have a quick recap. And then there is an end-to-end exercise-based chapter about image caption generator. So image caption generator is always a model that involves the CNN component for image processing, but also the LSTM component for generating the the text. So this is like a good example for overviewing deep learning, and all of this is done using PyTorch. So this intends to give a holistic coverage of the language. And in the second section, first we go deep into the CNN architectures, the evolution. So we discuss right from the beginning of when the first convnets arrived all the way to efficient nets. We go into the details of these architectures and implement them using PyTorch. Similarly, in the next chapter, we go for RNNs in a similar vein, going through the evolution of RNNs into LSTMs and so on. And finally, there is a chapter on other advanced architectures with a special section on transformers, again using PyTorch to code transformers. The third section, as I said, is really focused on applications. So we'll begin with applications such as music generation or text generation. So as you can see in this figure, this is like a beam search generation algorithm using a transformer-based model. Then there is a chapter on neural style transfer, where we intend to transfer a style of one image and the content of another image into a third image altogether, as you can see in the diagram. There is then a chapter on GANs with a specific focus on deep convolutional GANs. So in this image, you can see a UNet architecture is being used as a generator for pix-to-pix architecture, actually. So again, using how do we use PyTorch to efficiently code GANs? And then finally, the chapter on deep reinforcement learning basically has an end-to-end example of training a Pong video game agent. And it goes through the life cycle of how we can make incremental improvements, going from a simple Q network model to a DQN model coding in PyTorch. And finally, the last section of the book, which is focused on engineering, first goes through the different ways of productionizing PyTorch models. There is a lot of like exercises around scripting, using Torch script to make the models readable in C++ and so on. Also, there is a section on being able to use PyTorch in the cloud, in the different cloud platforms such as AWS and Google Cloud. Then there is a specific chapter for distributed training, just to make sure that we make the best out of our hardware while training or even evaluating our models. Then there are, like, the last 3 chapters of this book are really focused on the PyTorch ecosystem. So first up, there is this auto ML with PyTorch. So think of neural architecture search or just hyperparameter search. So there is a library called Optuna, which can be used with PyTorch very efficiently to do these kind of tasks. And similarly, there is a chapter specifically on interpretability. So there is a very well written library called Captum, which can be used with PyTorch once again to interpret. So this is an example of an MNIST model, and it's trying to look at what the different layers of the convolutional network are really focusing on in the image. And the last chapter is about rapid prototyping. So using libraries such as FastAI or PyTorch Lightning to be able to quickly prototype and experiment different deep learning models in very few lines of code and using relatively less amount of time. So I think that's like a quick overview, more or less, of what this book really contains. But before I wrap up, I just wanted to give a feel of how the exercises are laid out. So I'm going to refer to the first chapter exercise and gonna just run through a quick notebook. The notebook is a very simple task. It's basically the classic MNIST classification task, but basically what we do in the exercises is we go through these steps of defining a convolutional architecture, as you can see, with the initialization and the defining the forward pass of the model with the convolutional and the fully connected layers. And then we define the training and the testing routines. So the routine basically is all about iterating through a data set, and in each iteration, in each batch, we get the predictions, we compute the loss, and we back propagate the loss. So all of these steps are explained in the book, like what do these lines of code mean, and we also print after every certain number of batches what the progress or what the training loss looks like. And similarly, you have some testing routine, which is very similar to the training routine, but performed on the test data set, and there is no back propagation going on here, obviously. There is then, so after we define the model, define the training and testing routines, we also actually load the data set, and we define the optimization, which is, in this case, it could be Adam, it could be SGD, but I just use ADA delta here. And this is something to be experimented upon. And after that, you just begin training the model. And as I said, after a few hundred batches, which is 3,200 data samples in this case, you keep noticing the progress of training. While it is training for us, I can just quickly show you how in the book this looks like. So as I said, it goes through the different steps. It explains why we are defining a certain model architecture, how are we doing that according to the diagram with the explanations, and then we define the training and the testing routines, going through the data loading procedure. And after defining the optimizer, we go through the training and actual model training and testing loops. So as you will see, the model trains for 2 epochs here just for demonstration purposes. And after the first epoch ends, there is the testing routine, which is being called on the entire test data set of 10,000 samples in this case. And you see that the model actually performs relatively well, 98.28%. And the training loss goes down from the starting point of 2.3 to 0.02. It is still fluctuating a bit, but that is more or less expected during model training. And the same process is repeated for the second epoch, wherein the model is trained over the 60,000 training data samples, and the training loss is expected to reduce. And at the end of the model training epoch, we again compute the results on the test data set. So as you will see, there is a slight improvement from 98.28% to 98.5%, but that's not even the point. The point is, the goal of this exercise is to explain how do we go from how do we actually perform the entire end-to-end deep learning, machine learning modeling using PyTorch in the various steps. Once we have finished the model training loop, the last step is to actually use the trained model and perform some inferences. So I'm going to use a test data point which has a digit 7, and we are going to first run the model prediction and compare it with the actual ground truth. So in this case, it supposedly, it apparently comes out to be a correct prediction, and we could play around with more of such data samples, and we would hopefully see most of the time the predictions being correct, given that the accuracy is 98.5. So yeah, this was just to give you an idea of how the exercises in the book look like. As I said, it's a very applied book in nature. So every chapter has at least one and even more exercises. And the goal of the book is really to make people hands-on by using PyTorch for different kinds of applications. And with that, I would just say that the Mastering PyTorch book is available on Amazon. So yeah, that would be it from my side.
All right. Thanks, Ashish, for the presentation on PyTorch. We have a few questions from the audience already, and let me project the first one from Edmund. He asks "Hey, why did you choose PyTorch as opposed to other ML frameworks like TensorFlow or Keras, which is mostly said to be relatively simpler?" I guess that's a contentious statement, but I'm curious to know what your opinion is.
Yeah, happy to answer that. So actually, PyTorch is amongst the first deep learning frameworks which came up with the eager execution framework, and as opposed to TensorFlow 1.0, which had the deferred execution where the computations are performed after the entire deep learning graph is computed, which got changed after TensorFlow 2.0. So that is always one point of contention between PyTorch and TensorFlow. The second point was PyTorch is really more performant in terms of hardware usage, especially when it comes to GPU and especially when it comes to sequence models. So those were a few of reasons why I would personally choose PyTorch more than TensorFlow in my working experience. And that was the reason why I chose to write the book on PyTorch. But really, to be honest, my goal was to make the book applied in nature. So I might as well could have used the, TensorFlow as my medium. So the PyTorch is really just a medium to show how we can actually do deep learning. We could even use TensorFlow 2.0 for doing that. Regarding the ease of use, I personally find PyTorch's APIs more convenient, and it's more Pythonic, as it's always being said. So you can more easily debug your code because of that, as opposed to TensorFlow. But I also admit that ever since TensorFlow has taken Keras in their 2.0 API, it's also becoming more and more slick. So yeah, it's a very healthy competition between these two frameworks, in my opinion. And I just chose it because I happen to use PyTorch more in my work.
All right, cool. Next question is from Istvan. We all know the success stories of deep learning in image detection and NLP. In your experience over the years, what applications of deep learning have surprised you beyond those classical examples?
That's actually a very good question. So to me, reinforcement learning examples come to mind immediately, because I have also been using now in my work a lot of reinforcement learning to do even simpler tasks, thanks to a lot of simpler APIs that are available. And besides just the classical computer vision or NLP classification of tasks, there's a lot of hybridization that's happening. So think of using CNNs for audio, like in wavenets, or think of using transformers, which is not a recurrent model by design, for sequential data. So a lot of hybrid approaches are coming in. There is also a lot of development in neural architectural search. So what I mean to say is, it's no more it's getting to a point where we are not defining what kind of layers do we want. We are just letting the system figure out itself what kind of layers are the most optimal. So I'm really curious about these kind of developments which are meta, which are going beyond just like these two classifications of image classifier or object detection for computer vision and sentiment analysis or text classification for natural language processing. So it's going a bit more abstract than that, and that's a very like really exciting development in my opinion.
All right, cool. And then a question from probably an ex-colleague of yours, I'm not sure actually, from Lien. How much time would you say you spent writing each of the chapters? Lien, is that a question because you have ambitions as well to write a book? Did you feel like you learned something while writing the book as well? I'm curious about that one.
So Lien is indeed an ex-colleague, and hello to Lien, and a dear friend of mine. So that's actually a good question. So each of the book chapters, I would say it really varied because some chapters were long, some were short. But on average, each chapter took 3 weeks to write. But that was just the first draft. You always have to remember that the reviews keep coming back to you. So that's something I learned along the way and the hard way, to be honest, that it's not just the first draft you write. You have to keep getting back like requests to review, and sometimes the reviews could be like drastic, like half of the chapter needs to be rewritten. So it really depends, but I would say 1 month kind of time is reasonable to expect for each chapter. And there was a second part to the question as well, Kris.
Yeah, just a sec, I'll bring it back. Did you learn something, or did you feel like you learned something while writing the book? Yeah.
That's another excellent question. So I have to again admit, I learned actually a lot while writing. So what happens is, while you're writing a book, you have to be really, really sure about what you are writing, because once it's there, it's there. So you have to do plenty of research. So on the topics where I am already quite confident, I solidified my understanding by reading more. But there were topics which were required by the publisher, let's say, that they must be there, and which were not my areas of strength. Then that's where I had to actually go and study loads of blogs, loads of articles, loads of literature, and actually learn lots of new stuff while writing the book. So that's 100% a fact that if nothing, you learn a lot while writing a book. Yeah.
All right, cool. Well, I have one last question myself, and it might be a question coming from ignorance, right? So tell me if I say something stupid, but I'm more on the engineering side of data. And when we come in contact with deep learning solutions or use cases that use deep learning frameworks, more often than not, what we see, they don't even use GPUs. So it's a relatively small data problem that can run on relatively standard hardware, I would say. If you see such a solution in real life, do you say like, you're an idiot, you should have written that in sklearn or something is much easier? Or is there a place for deep learning solutions for, let's say, modest scale data that don't need GPU or massive compute power?
So yeah, if I understood your question correctly, yes, there are so many problems where it's a small data problem, but just because the nature of data is such that it's not inherently structured. Let's say it's not even tabular data. We are talking about images. Most of our sklearn based algorithms will fail mostly. So we will need to use some kind of a deep learning approach in many of such cases. That's where deep learning actually comes to shine. And I agree that there is kind of a fear associated with, oh, I have to use now TensorFlow or PyTorch, and that's like a lot of verbose code lying around. But that is where one of the chapters in the book is about rapid prototyping in PyTorch, and I can like only suggest you to actually go through that chapter. It has a section on fast AI, which aims to make it so short, like the number of lines of code you need to even put together a complex model is like less than 50 for sure. So it really makes it look more like sklearn than the old TensorFlow style. So it really is very inviting in terms of being able to code even small data problems, even small problems using deep learning. And about the GPUs, it is really up to our own like wisdom. So if we see that there is a advantage of using GPUs, then we must, and it really pays off for the large models, extremely complex models. But for like small scale, I don't think there is that's the biggest concern one must have, whether to use GPU or not.
All right, thanks.
Yeah.
In the meantime, a few extra questions have popped up and we have some time left. So if you don't mind, I'm going to keep on
Sure.
firing questions at you.
Mhm.
Le Q Duong, sorry, man, if I butcher your name, my apologies. But what is the prospect of using PyTorch in classical numerical simulation tasks, something like solving ODE?
That's an excellent question. And so a bit of trivia, PyTorch is actually, it came from Torch, which is supposed to be actually a numerical, it was written in Lua, that scripting language, which was supposed to solve ODEs and like numerical computation problems. So I am pretty sure, although I'm not an expert in that particularly, but I am pretty sure that one must be able to use tensors, the APIs that PyTorch provides to be able to solve ODEs. I'm 100% sure about that, because ultimately even deep learning is just a computational graph. And I believe you can also pose the ODE equations in matrices form, in the form of a computational graph. So it's just a matter of looking it up. I am not an expert on this, but I know conceptually that it's possible to do it with PyTorch.
All right, cool. There was one more from Ashok Tak. He says, "Hey, great presentation. I'm loving this book. What do you think about ML ops tools along with PyTorch?" I'm actually interested in that one as well. So good question.
Yes, for this one again, I really strongly encourage to visit pytorch.org/ecosystem. So PyTorch has a lot of like evolving toolkits around like the library itself. So some of the examples I have already discussed in the book, but it's impossible to cover all of them. So there is like a lot of like ML flow kind of tools. If Ashok means those kind of tools around managing experiments, there is a lot of tools around auto ML, which is one of them I have shared in the book as well, which is called Optuna. It will be impossible for me to spell them out here, but I can only assure you that there is a very rich ecosystem of tools around PyTorch, and just visit pytorch.org/ecosystem and you should be able to get hopefully the tool around what you're working on, because I'm talking about at least 20 to 30 rich set of libraries already in place.
All right, cool. People are really using this moment to extract all the knowledge from you, right? So I hope you don't mind. So, but here's another one from Carlos. He says, "Hi Ashish, thanks for the PowerPoint. I know it's a bit off topic, but do you have any suggestions for learning Pyro, which uses PyTorch besides its documentation?"
Yes, I think Pyro is one of those which I just mentioned in the PyTorch ecosystem. I did not add it in, did not consider it for the book, because there were already some other similar libraries that we have discussed in the book. I am pretty sure about the documentation of Pyro. I think they have well-written documentation, because when I was researching for the book, I did go through Pyro, and I actually tried out some of their examples, and it does like work, unlike many GitHub projects, which really, you know what I'm talking about, they break at some point. But I have experience of working with Pyro, and I can assure it works. It's just a matter of looking into the documentation, and also looking into pytorch.org, because they also might have an example with Pyro.
All right, cool. I think with that we can wrap up. If people have more questions, I mean, keep them coming in the comments, and maybe Ashish is kind enough to answer them on YouTube. But I would say best of luck with your book. It's a great accomplishment. Congratulations on publishing it in the first place. It's interesting to see also the journey, that it's not just about, yeah, I have something in my head, let me do a V1, send it over, do some typo checks, and then publish. No, it's
Yeah.
it's a lot of iterations I've learned. So
Yes.
so I have zero ambitions to do that ever. But
Yeah. One last, like on a lighter note, writing, like if you're doing it for making money, please don't do it.
Yeah, Lien, that's a tip for you. So I don't know what your motives are here, but if you're maybe wanting to write a book, because here Lien said maybe. So if you maybe want to write a book, maybe consider not getting rich out of it, I guess. I've heard it from others, by the way, but I guess it's, well, besides just being intellectually satisfying, it also puts you on the map, right? So if I want to master PyTorch, that's the guy, right? Because he wrote the book on mastering PyTorch, so it's pretty cool. I mean, again, super cool. Best of luck with the book, and thanks for showing up here at Data Science Leuven and share all your knowledge with the community. Thank you very much, Ashish.
Thank you, Chris.